This is really just a quick video to show you the physical layout of the myDAQ and the breadboard, explain how it works. So the myDAQ has a number of inputs and outputs that are described along the side here, and the breadboard has inputs and outputs that also mirror those of the myDAQ. So the pins on the breadboard are kind of connected straight through to the small bit of breadboard here. The actual main breadboard is not directly connected to any of the pins on the smaller breadboard, and you have to use wires that loop over onto the breadboard over here. Importantly for the first exercise, we'll be looking at the analog input channel 0 and using this to read the intensity of a light emitting diode. On the breadboard itself, there's basically two sections of the breadboard. There's what we'd call the power rail, where we'd wire up positive and negative voltages that we can then use within the circuit that's in the main section of the breadboard. On the power rail, all of the pins along a row like this are connected all together, but the negative and positive power rails are isolated from each other. The main section of the breadboard here, the pins are wired up in the other direction, perpendicular to the wiring on the power rails, so that any component plugged into a column here would be connected to any other component that was also plugged into the same column. Going across the kind of central dividing section here, these columns are no longer connected together. So this column here is isolated from this column up here. The central dividing section is there so that we can plug in integrated circuits like our op-amp, so the pins go into separate columns on each side of the central rail. So when we come to take our photodiode component, we would plug it in so that the legs went into different columns here. Just notice that the legs there are shorting together, so I'm trying to twist it around. Okay, so here we've connected these legs to a different column, and then we connect from the column to the analog input. Actually, we're going to go through a resistor, aren't we? So we plug the resistor into the breadboard so it's connected to one of the legs, and actually we're going to measure the voltage across the resistor to measure the current. Plug this in. So there is our kind of voltage sensing circuit. The current is going to get generated by the photodiode, pushed through the resistor, and then we're going to monitor the voltage across the resistor. That'll tell us what the current through the resistor is. We also need to bias the photodiode. So on one of the legs here, we'll connect up to 5 volts, which we can do on the smaller breadboard at the back. That's ground, actually 5 volts here, and the other side of the photodiode, which is through this resistor leg, we're going to put to the analog ground. And there are lots of different analog grounds on the rail here, one here and another one here that we could use, it doesn't matter. Okay, so now our photodiode is biased using the 5 volts to ground, and we'll create current that gets forced through the resistor and monitor that current across the positive and negative terminals of analog input channel 0.